So here's a charging circuit for RC. So you need a pretty good capacitor. So these are 5.5 volt 1 farad. We've got some other ones, 5.52 farad and 5 farad, going through to a 3 volt globe. So we've got up to 3 volts, and if we just put voltage straight across the globe, we can see that it's pretty bright. And then what we're going to do is we can connect it in series with the capacitor, and as the charge goes on, you'll see that the voltage across the capacitor starts to go higher, and the voltage across the bulb goes lower, and this, the current charge is clicked on the capacitor, the bulb starts to go dimmer and dimmer and dimmer. And if you put a voltmeter on here, or a digital voltmeter, you can see a lovely exponential graph. And so now it's fully charged, although you can still see that there is a little bit of current going. And eventually that will drop to 0. And then what we do is we just disconnect that one, and now we can show a discharging graph if we're very careful and only touching one of the pins. And now we can show the opposite, that we're taking energy out of the capacitor, and that initially it was really bright, and as the capacitor discharges, the brightness goes down and down and down until essentially the current dissipates to 0. We'll try it again now with a 5 farad capacitor, and you can ask the pupils what do you think will happen. And so if you're looking at the idea of RC, the C is bigger, and so the time constant should be bigger, and so this will take a long time to go dim, and a long time for this capacitor to charge. So you can see the current there at 0.22 amps is staying quite high for quite a long time, and so a larger capacitor means more charge stored, a longer time constant, and you can watch that for a long time, and you can discharge it in the same way.